Hi everybody, welcome to the second video for tonight. We're going to continue on with systems of equations. In this video we're going to be talking about the elimination method. And as you've heard me in class a few times by now, I want you to kind of understand that there's varying levels of difficulty with using elimination. And I want to go through and give you one example of each of the difficulty levels, and so that you're kind of prepared and you can see what to look for. Again, when we use the process of elimination to solve systems of equations, we're looking for two variables and their corresponding coefficients that are opposites of each other. So that way we can just simply add the two equations together. Because those opposites will cancel each other out, that is what we've been affectionately calling the Houdini step in our class. In other words, once we add those equations together, the two variables that are opposites of each other, when they add together, they're going to add to equal 0. And therefore, they then are no longer part of the equation. We've now removed one of the two variables from the system, and so then we could just solve for the other variable. Once we do that, of course, then we're right at the same spot as we are with substitution. Once we solve for our first variable, we take that value and substitute it into one of the original equations, and then solve for the other one. So again, starting from least to more difficulty, a first level difficulty, if you will, is as the problem is written, the opposites are already there. So this is example number 17 on our practice test. If you see here, we have a negative 9x plus 5y equals a negative 10, and then we have a positive 9x plus 7y equals a negative 4. So again, without having to do anything to set these up, since they are already opposites, I can simply add the two equations together. So when I add a negative 9x plus 9x, I get 0x. I wanted to put that in kind of that reddish color at first, just so that we can keep it a little bit separate. So now that variable, the x variable, is going to disappear. But in this case now I have to go ahead and continue adding both equations together. I have a negative 5y and a positive 7y. That's going to leave me a positive 2y. And then I have a negative 10 plus a negative 4. That's going to give me a negative 14. So I'm going to divide both sides by 2. And I get y equals negative 7. Now again, I take that negative 7, I plug it into either of these two equations for y. I'm going to go ahead and use this equation on the bottom. So now I have 9x plus 7 times a negative 7 equals negative 4. And again, I remind you, as a hint, when you're substituting this value in for your variable, y equals a negative 7, so I'm putting a negative 7 in for that. Make sure you put it in parentheses so that you can make sure that this sign is staying with the variable. So now I have 9x plus, now I have a plus 7 times a negative 7, so I have 9x minus 49 is equal to a negative 4. I'm going to add 49 to both sides. 9x is equal to 45, and divide both sides by 9, and I get x equals 5. So the solution for this particular problem in my ordered pair is 5 for the x value and a negative 7 for the y. Again, the key here is to understand that in order to use elimination, in which we're adding two equations together, we have to have opposites. Once we have the opposites, then one of those variables, the ones that are opposite, are going to disappear. And we no longer, as you can see here, I used a different color, we no longer have to write 0x. We now have just what's left. We can solve for y, substitute y into the original problem. The second level of difficulty for using elimination as our method for solving systems is in which we don't have opposites right away, but it doesn't take us very long to get there. So again, I'm going to erase this, pardon the pause, and I'm going to do number 19. So if you want to jump down on your practice test to number 19. And that's going to be a negative 2x minus 2y equals a negative 30. Below that we have 8x minus 5y is going to equal 16. So again, I'm looking at the four variables, the 2x values, the 2y values, and I'm looking and comparing the coefficients. So I have a negative 2 and an 8, a negative 2 and a negative 5. So to me, that tells me that since I don't have any opposites already, I need to multiply all of the terms in one of the equations by some factor in order to create my opposites. And again, we're allowed to do that. It's the exact same process we do to eliminate fractions. Again, the theory is that if we multiply all the terms in an equation by that same factor, all we're doing is making that equation either keeping the ratios consistent, all terms bigger or all terms smaller. So the value of that equation doesn't change. Okay? So with that, I can see here that if I was to multiply this first equation by 4, I would be able to get a negative 8, which is what I'm looking for to create an opposite from my positive 8 right here. Again, I wouldn't want to do the 2 and the 5 because there's nothing I can multiply a negative 2 by in order to get it to a negative 5, and vice versa. There's nothing I can multiply a negative 5 by and get to a negative 2. So I would have to do both equations if I was to pick the y variable to create my opposites. So in this case, half of my opposites are already done. I'm at a positive 8x. All I have to do is multiply this first equation by a 4, and then that would create the opposites that I'm looking for. So just above it, I'm going to go ahead and write the new equation. Now 4 times a negative 2 is going to give me a negative 8x. 4 times a negative 2, again, negative 8, this time it's y, equals, and then 4 times a negative 30, this is a negative 120. Okay, so now I'm going to add my two equations together, and the x values just canceled out, so I have a negative y and a negative 8y and a negative 5y is going to give me a negative 13y is equal to negative 104. Again, that's a negative 120 plus 16 is a negative 104. So now I'm going to divide both sides by a negative 13, which is nice because now I know my y is going to become positive. And I get y is equal to 8. So again, the process is we multiplied one of the two equations and got a new equation, by the way. Again, it's just number 19 on the practice test. Okay, so I've just made this first equation larger by a factor of 4. I dilated, if you will, if you recall back from our previous lessons. So I dilated this equation by a factor of 4 and got my new terms. And then I was able to create the opposites here. So now the x values were able to eliminate once I added the two equations together. Okay, and then negative 8y, negative 5y is going to give me negative 13. Now that I have y equals 8, I can choose either one of my original equations and substitute in 8 for y. I'm going to go ahead and go with the second one. So I have 8x minus 5 times 8. So even when it's positive, put it in the parentheses so you make sure that you keep it, any signs that might be attached to it. You still want to get in the habit of doing that. Okay? And then equals 16. So I have 8x negative 5 times 8 is a negative 40 equals 16. I'm going to add 40 to both sides. 8x equals 56. I'm going to divide by 8. X is equal to 9. So now I have a value for x, I have a value for y. My ordered pair answer is 9, 8. Pardon me. How about a 7? That looks a lot better. 8 times 7 is 56, not 8 times 9. 8 times 7 is 56. So 56 divided by 8 equals 7. X equals 7. My answer is 7, 8. Okay? So again, that is the second difficulty level. And probably not the last time of a reminder. This is the most difficult that you will have on the AZ merit test. Okay? On the quiz tomorrow, there will be an extra, not quiz, on the test tomorrow, there will be an extra credit question that goes into a higher difficulty level, but the normal problems will be just of that same difficulty level. So speaking of the higher difficulty level, I'm going to do one more problem, and this is number 24 on the practice test. And that is the situation in which we need to multiply both equations by some sort of factor. Negative 8x minus a negative 8y equals a negative 18. And then negative 5x minus 5y is going to equal a negative 15. Okay, so again, what I'm looking for is opposites that I can create because there's none visibly there. And I want to look to see if I can multiply either of the two equations by a single factor in order to create my opposites. And it doesn't appear so. I can't multiply 5 by any number that's going to give me a negative 7. I can't multiply a negative 5 by any number that's going to give me a negative 8 either. And vice versa. There's no number I can multiply a negative 7 by in order to get to negative 5. And there's no number I can multiply this negative 8 by in order to get that negative 5. So essentially what I'm going to have to do, and it's the exact same process of finding the lowest common denominator. In this context, we're going to say that what we're looking for is the lowest common factor. So the lowest common factor between these two numbers. So I can choose at this point because as I've just gone through that process, I've realized that I can create opposites in the same amount of steps for my y value as I will for my x. So it's just a matter of choice at this point. And looking back at my notes, it looks like I went ahead and on the answer key, I went ahead and tried to eliminate my x values first. So how would I get to a number that would cancel out? Well, in this case, 7 times 5 is the lowest common factor between the two. So I'm looking to get to 35. So I want this to be a positive 35 and that to be a negative 35 or vice versa, but one of them has to be positive and one has to be negative. So what I'm going to do is I'm going to multiply this whole first equation by a negative 5. I want this to turn out to be a positive, and then I'm going to multiply this whole equation by 7. So please make sure that you understand where that's coming from. This 7 is from that coefficient right there. We're not worried about the sign right now, but that's where that came from. This 5 came from this 5 as well. Since they're both negative, I had to choose one of these two to be negative so that one of their signs would change, and I would have one positive and one negative. I just chose to do the negative up top. So I have a negative 5 times a negative 7x is going to give me 35x. Negative 5 times negative 7 is positive 35. Negative 5 times a negative 8 is going to give me a positive 40y. And then a negative 18 times a negative 5 is going to be a positive 90. So that's the first equation rewritten after I've multiplied it by a factor of 5. Now I'm going to do the same thing with the second equation, except now I'm multiplying it by 7. So 7 times a negative 5 gives me a negative 35x. A positive 7 times a negative 5, again, negative 35y. And then a 7 times a negative 15 is a negative 105. Okay, so with that, I'm going to add my two equations together. As I can see, I just created this scenario where now I have opposites. I have a positive 35x and a negative 35x. So when I add them together, I get 0x. And as we talked about in class, that once we get to big kid math, we don't even write that term anymore because there's 0 of them. So we're going to add a positive 40y plus a negative 35. That's going to give me a positive 5y is going to equal a negative 15. Divide both sides by 5. Y is equal to a negative 3. Now, as always, I'm going to take this negative 3 and plug it into either of my two original equations. I could very well plug it back into either one of these. I want to be clear about that. All of these equations, all they are magnified by these factors or dilated, enlarged by those factors. The ratios are still the same, so the value of y is still the same, the value of x is still the same. It's just that they're much larger numbers. So I probably wouldn't want to put my negative 3 into one of my two manipulated or altered equations. I'd probably want to go up top in one of those two where the numbers are relatively smaller. So I might as well just go on and use the top one. So I have a negative 7x minus 8 times, now y is equal to a negative 3, so if I see that, I can just put that as a negative 3. That's going to give me equal 18. It just looks like we're getting a little close. I'll draw a line separating the two. Okay, so this is substituting this negative 3 in for y in the original equation. So I have a negative 7x, negative 8 times a negative 3 is a positive 24 equals a negative 18. I'm going to subtract 24 from both sides. Negative 7x is going to equal, those are both negative, so my number is actually going to get more negative. So 8 and 4 is 12. Bring 1 up, 2, 3, 4. So now I have a negative 7x equals a negative 72. I'm going to divide by a negative 7. X equals 6. That's a positive 6 because I divided the negative 42 by a negative 7, and I get x equals 6. So my final answer for number 24, written in coordinate form, 6 for my x value, negative 3 for the y value. And there's my answer. So again, the process is exactly the same on all of the difficulty levels. The differences, though, in the amount of difficulty level is really just the amount of work that's needed in order to create the opposites. In the level 1, or the easiest or least difficult level, the opposites already exist. So there's nothing that you need to do to the equations. You simply add them together. The opposites disappear, which leaves you just one variable, and you solve for it. The next level of difficulty is when you're going to have to multiply one of the two equations by some factor in order to artificially create your opposites. Then when you add them together, those opposites, of course, just like before, will disappear, and you solve for the other variable. The process continues as the same. And finally, the third and most difficult level is where you would have to multiply both equations by some sort of factor, because simply multiplying one of them is not going to get opposites. So you have to look for the lowest common factor between the two coefficients of the variable that you're trying to eliminate. In other words, I'm looking at the coefficients of these two. The lowest common factor between the two is 35. In order to get to 35, I have to multiply this equation by 5 and this one by 7. And that's how I came up with this 35 and this negative 35. All right, well, thank you very much. If you have any questions, I do have duty Tuesday morning, so I will try to be out in the breezeway with a whiteboard. But if you have any questions, let me know. Good luck on the test. I'm sure you're going to do great. Thanks so much. Have a good night.